Okay, continuing here on Friday the 25th, ice day, with number 24. Photosynthesis reactions in green plants use carbon dioxide and water to produce glucose and oxygen. Plant has 88 grams of carbon dioxide and 64 grams of water. You'd have to know, to get this started, that water is H2O. You'd have to know that carbon dioxide, in words, is CO2. The phases really don't matter on this. Without getting way down in the weeds, these, this is all occurring molecule by molecule inside of stroma inside of cells. So it really doesn't matter what the phases are too much for the purposes of this. Now it wants you to balance this. Okay, I have 1 times 1 is carbon, 1 times 6 is 6. So I need it to be 6 times 1 is 6. Let's save the oxygen because it's here, 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 and here. Hydrogen, I have 1 times 2 is 2, 1 times 12 is 12. So this needs to be 6 times 2 is 12. Now it's time for the oxygen. 6 times 2 is 12, 6 times 1 is 6, those 6 and those 12 is 18. On this side I have 1 times 6 is 6. I don't want to change this because that changes everything. So 18 minus this 6, I have 12 left. This must be a 6. You've seen this reaction before in biology. Okay, the first question is determine the limiting. So I'll use this one to determine how much of this one we need. Figure out which one's limiting. That will be B. The excess will be the other one. And then we'll probably do the mass of glucose produced first, like I did last time, to get a product, and then use the product to finish this excess. There are other ways to do it, but since we did the last one that way, and that's pretty intuitive, I'll probably find that simpler. Okay, so to do this one, we're going to find this guy. Equals X grams water. X equals so many grams water. Needed to use all of this up. We'll get a number, and that number will be bigger or less than this, which will tell us which one's limiting, which one's excess. Then we start with what we know. 88.0 grams of CO2 over 1. Okay, we are going mass to moles to moles to mass. So you know this, the whole thing. With that, that's typically the case because we can measure masses. So grams, we're going to have this carbon dioxide playing the role of A, water playing the role of B. Okay, so the next thing is moles A. So that's moles, CO2 playing the role of A. Moles B, that's moles H2O playing the role of B. And then grams of B, grams H2O. All right. And this goes here, this goes here, this goes here. So grams CO2, moles CO2, moles H2O. So where do the numbers come from? I'm going to go to purple. Well, the numbers for the first set of, okay, I didn't point this out last time, but I added 1, 2, 3 sets of parentheses because I'm going through 1, 2, 3 arrows. I think we're okay on that. The numbers that come from the periodic table are for a mole always. And for CO2, you add a carbon and an oxygen, that's 16 and 16 and 12. is 44. For water, 16 and 1 and 1, that's 18. And then these numbers come from the periodic table. Don't change them, okay? That's an extra step. Just leave it as 6 and 6. Okay, this cancels, this cancels, this cancels. Make sure you're having everything written out in words. So that these cancel. I even cancel in different colors. These cancel. These cancels. Okay. Now, I can just about do this one in my head. 6 over 6 is 1. 88 over 44 is 2. Double 18 is 36. So you can punch that on a calculator if you need to, but I don't need to do that one. We need 36 grams of H2O. Okay, now, which one is excess and which one is limiting? If we need 36 grams of water, we've got 64. Is that limiting or excess? About half the time students pick the wrong answer. If we need 36 grams and we have 64, this is excess. Label it. Therefore, this one is limiting. Now, just in case I made a mistake, let me check that. And I have B limiting CO2, H2O is excess. Now, I'm going to skip to D and find the product. And then I'll use the product to find out how much of this I consume. There's other right ways to do it. You may have done it another right way. But I'm going to find D first, determine the glucose produced. Okay, so what I'm going to do is edit, copy, edit, paste. That should be here. So I'm going to do part D. I'm going to find the glucose produced. And then I'll use the glucose produced to find out how much of that I used and subtract. There are other right ways to do it, but that's probably the easiest for you. So we'll go with equals X grams C6H12O6. X equals so many grams C6H12O6 produced. Okay? And what we're starting with this time is the limiting. That's the big lesson of the day. Once you find the limiting, that's the one you're using. By the way, I was talking about excess and pointing to this one. This is the excess. Grams. 88 grams of CO2 over 1. So this is going to play the role of A. This is going to play the role of B. So we're going to do grams CO2 to moles CO2. I have 1, 2, 3 arrows. We're going grams to grams. I think we're going to grams. Let me check. Looks like it. Okay, moles of B is moles. C6H12O6, 2 grams, C6H12O6. Okay, then this number goes here, grams CO2, this number goes here, moles CO2, or these units go here. These numbers go here, moles C6H12O6. Okay, so from the periodic table, I need the moles and the moles. So every mole from the periodic table, which is based on 1 mole. Okay, CO2 is 44. We had that from the previous page. I happen to know that glucose is 180. Let me double check that. 6 carbons times 12 is 72, I think. Just double check that. Okay. 12 times 6 equals, okay, 72. And then oxygen 16 times 6 equals, I'm going to add 7. That's 168 plus 12 for the hydrogen is 180. Okay. Then I get 6 CO2s from the balanced chemical equation, give me 1 of this. So this is also going to be easy to do with the calculator. So 88 over 44 is 2. And 180 over 6 is 30. And 30 times 2 is 60. So you can punch in the tops, write the answer down, multiply the bottoms, write the answer down, then divide, you'll end up with 60. Okay? That's how many grams are produced. I'm going to write that up here in blue. And then the next step is, I'm going to go back and do part C. I'm going to use this to determine how much of this we consumed and subtract it off and get the excess, just like last time. So edit, copy, edit, paste. The difference is, I'm going to go part E this time. C this time. And I'm going to go equals X grams of H2O consumed. And X is equal to so many other grams H2O. Now, remember, I'm going to take the grams that I have, which is 64, and I'm going to subtract the grams consumed. And the rest of it is grams excess, or grams remaining. Okay? So let's start with what we have over 1. We're starting with 64.0 grams of water over 1. And let me repeat this. This time, this is A, and this is B. This is A, what we end up with. B is we're trying to find out what we started with. So we're going, actually, this needs to be, this is wrong. Aha! The first term is wrong. What should it be? It should be 60 grams of glucose. That's what we're saying. Okay, we knew we made that. How much of this did we use? Okay, C6H12O6 over 1. Okay, I'm going grams to moles to moles to grams. So grams to moles, C6H12O6. One arrow, one arrow, one arrow, 3 sets of parentheses. To moles, B, H2O, to grams, B, H2O. Okay, this goes here. Grams C6H12O6. Moles, this goes here. C6H12O6. This goes here. Moles H2O. From the periodic table, a mole from the periodic table has a mass of, we've already determined these, water is 18, glucose is 180. By the way, that's a tenth. So far we have 6. You don't even need a calculator for this one. A glucose, 6 moles of water. I think the grams consumed is 36. Let's take a look at this. This is a 1 to 3 ratio. 6 divided by 3 is 2. Double 18, 36. Alternatively, you can multiply all the tops, write it down. Multiply all the bottoms, write it down, then divide. You'll get 36. Okay, so if we consume 36 grams, and we had 64, that's what, 28 grams of excess H2O. Yes, that is. So that one's done. One more video.